Hello, today we are going to be working on lesson assignment, Chords and Circles, Part 1. Okay, so let's go ahead and look at the assignment. First of all, let's go ahead and open this right here, okay? We're going to look at a few things that we're going to use to do this assignment. Okay, so when we open this up, we get circle chord theorems. You should be able to translate this to your language if you need to translate, okay? Translate. So make sure you translate if you need to. And then let's go ahead and get rid of this, okay? So what are circle chord theorems? First of all, you may want to spend some time on this. You should know some of these by right now, but these are really good vocabulary about circles, okay? And then this is a good picture. You should already know that a radius is from the center to the edge, diameter all the way through. So if you want to spend some time on this, you can. The important thing is that a chord is a line that goes from one edge of the circle all the way to the end of the circle. And the diameter actually is a chord. It goes from one end of the circle all the way to the other, but what's a very special chord because it goes through the center. But these are chords, okay? And so these are the important things that we need to know today. Diameter, radius, and chord, especially with chords. Of course, arcs as well. We need to know arcs. A major arc goes more than halfway around the circle, more than 180 degrees, the green one. The orange is a minor. They call it minor or small arc, which is less than 180. Okay? All right, so let's go ahead and look at the first principles of chords. I'm going to go ahead and exit out on this. So again, you make sure to translate if you need to translate this, okay? The first thing is this. If you get a circle like this, and it's perpendicular line from the center of the circle to a chord, and it bisects the chord. Remember, bisects means cuts the chord in half. So this green line, the blue line is the chord, okay? From A to B, that's a chord, okay? CE is also is a radius. It goes from the center straight through, and it cuts at a 90-degree angle. When it does that, that means A to D is X, whatever that is equal to B to D, because the green cuts it in half, okay? But it's only when the green line, or the bisector, is at 90 degrees. Let me give you an example. Okay, so let's say we have a circle, circle like this, right? Okay, and we have a chord like this, okay? That's a chord, and then there's a center of the circle right there. Let's try two lines. Let's try the red one. So the red one goes like this through the circle, okay? So when it does that, this is the radius, right? This line right here, let me do this real quick. Let me make it a different color so I can refer to colors. So let's make this line green. Okay, so when I make a line like this does not form a 90-degree angle. So this part right here is not equal to this part right here. So not equal, okay? This part, let's make this a different color. Let's make this blue. So this part right here is not equal to, let's say, this green part right here. So it's not equal. But if I go like this, if I go, let's take this line, maybe yellow. No, I don't know if you can see yellow. Let me do purple, okay? But if this line comes through and intersects it at a 90-degree angle, a right angle, 90 degrees, then it is equal, okay? So that means this piece right here is equal to this part right here. They're both X, so they're equal, okay? So that's the principle we're going to use today in the first several questions, okay? So again, it has to be at a 90-degree angle. That would make this equal to that. So let's go to the assignment and we'll look at the first few questions, okay? So go ahead and open it up in Canvas so you can take notes. Okay, so let's look at the first, let me make this bigger here. Okay, so we have that kind of thing, right? We have a chord right here, and it's cut by the 90-degree angle. So that means this is going to be the same as that. Okay, well, but they don't tell us what it is, right? They don't tell us what it is, so that doesn't really help us, right? But if these two are equal, and then this third one right here is the same, that means the third one is finally the same. That means that 19 right here, this side right here, is going to be the same as this. But not only do we know that, what are they both? This is not just the side of a right triangle. This is the radius, right? So whatever the radius is going to be the same. That means that the distance from here to here is also the radius. That's x. So it's 19. But what is this? this is also 19. This is also 19, because why? They're all the radius. So that's pretty easy, right? Okay, so that was pretty easy. Now let's go to number 2. So number 2 is, here we know that we're looking for x. So that's going to be this piece right here. Well, since this cuts this chord down a 90-degree angle, that means this and this one are equal. So very easy. This is the same as that. This is going to be 15. Okay, so that's one kind of question. We're looking for the length of the segment indicated. Okay, what about number 3? Okay, so let's look at number 3. So we're trying to find x, right? Trying to find x, that's going to be this piece right from here to here, right? What is that? Well, the important thing to know is that it's part of the radius. So the radius is this whole piece right here. So the radius is equal to x from here to here, and then 6.2 is from here to here. So x plus 6.2 equals the radius, right? Well, check it out. If you look around the circle, you see that the radius is also listed in 2 places. Number 1, it's right here, and it's 11. So basically that equals 11. So then we can just go minus 6.2, minus 6.2. And then x is equal to 4.8 when we use our calculator. Okay, very easy, right? Okay, if you want, take a moment to see if you can do number 4, and you can pause the video if you want, and then try it. Okay, well, what are we solving for? We're solving for x, which is in this piece right here. So we're looking for this piece. We know this is 5.1, so just like the other one over here, that tells us that x plus 5.1 equals the radius. Do we know the radius? Well, not this. It's got to go through the center, right? It's a line from the center. Well, here, 20.4 is the whole thing. So we have to take this. The radius is just half of it. That's the diameter. So 20.4 divided by 2 equals 10.2. That's the radius. So that means that's equal to 10.2. So minus 5.1. Sorry, this is 1. So x equal, oh, that's very easy, 5.1, okay? That's all there is to that, okay? So let's go to number 5. What are we doing on number 5? Okay, so number 5 is a little bit different, okay? So number 5, we're looking for x, which is this right here. We know this is 11.4 right here, right? 11.4. And we see that 12.1 is the radius from here to here. But it's also, since it's a radius, it's also right here, right? So how do we solve that? Well, here's the important thing. Remember, this is 90 degrees, so this is a right triangle. Do you remember how we know a squared plus b squared equals c squared? So we can use this, okay? So we're going to go 11.4 squared plus x squared equals 12.1 squared. Okay, I'll show you what I've done so far. I've squared the 11.4 to get 129.96. I've squared this to get that. I subtracted 129 from both sides, so right now I'm at that. Do you remember how to solve for x? Well, what we need to do is we need to take, to get rid of the square, we need to go like this, right? So 16.45. Okay, so I got to do the square root. It's this piece right here, so I got to go second square root 16.45, enter, and I get 4.055, which is going to, wow, this is close. Okay, well, the one that's closest has got to be this one right here, right? It's got to be D. Wow, that's kind of close, but I got 4.055, and that rounds to 4.1, right? So that's the closest, okay? So we're just going to have to pick that one. Okay, so number 6 is a lot like number 5, so why don't you go ahead and pause the video and try to see if you can find x and come back for the solution. Okay, so here's the steps that I went through to get the answer 4.47. This is one side, 9.5 is the other side, and 10.5 is the radius or the hypotenuse. Remember, the C is always a hypotenuse, and in this case, a hypotenuse is going to be the radius from the center of the circle to the edge, from the center of the circle to the edge. All right, so that's how you do those. So let's see, I guess we've got 2 more. Let's try, oh, these are very similar. I think you should be able to do these as well. So now you should be able to finish the rest of the assignment, and when you're done, make sure you come back, you enter your answers into Canvas, and then you'll be done. So that's how you do today's assignment.